All right. Good morning, everybody, and welcome to the webinar introducing the RTK functionality of the Archer 4 with the GNSS Expansion Pod. We appreciate everybody being here. Just in the way of a brief introduction, my name is Wyatt Peterson. I'm the Dealer Network Manager here at Juniper Systems. So work closely with all of our premier dealers throughout North America. A lot of them represent you and are your sales folks, so we appreciate your attendance, and they're helping us put this on and get everybody here so that everybody can learn a little bit more about the product. With me, I have John Florio, the Senior Product Manager that's over the RTK functionality and GNSS pod of the Archer 4. So welcome, John, and happy to have you.
Thanks, Wyatt.
All right. Just for anybody that doesn't know, for the last 30 years or so, Juniper Systems has been engineering, designing, manufacturing rugged tablets, handheld data collectors, and GNSS receivers right here in Logan, Utah, northern Utah. So here's just kind of a look at our current product offering. We now offer some software as well for use with our mapping products. So yeah, play in a lot of different industries, many of which you guys are part of. And yeah, that's just a little bit of background about Juniper Systems. We have a lot of values that we continue to quote and fall back on here at Juniper. The top one being we grow lasting partnerships to help workers thrive. That's kind of our why statement, our mission statement. And just want to, again, thank you all for your attendance today. We consider each and every one of you a customer and a partner, and appreciate your business and our working together in the past and as we move forward with new opportunities together. So thank you all. All righty, I'm going to go ahead and turn the time over to John. He's going to talk to you all a little bit about the Archer 4, some about the device itself, and then of course about the GNSS Expansion Pod and some of this new functionality we have for you. So go ahead and take it away, John. Thank you very much.
Thanks, Wyatt. Oh, by the way, if you're not familiar with using GoToWebinar, you'll notice that you have a control panel. And on that, you can submit any questions that come up while we're going through the presentation. We will have a little segment at the end of our session where we can answer some questions. And if we're not able to answer questions during the presentation, we can email out those answers to you.
Thank you, John.
All right. So what is the Archer 4? The Archer 4 is our newest handheld rugged computing device. As you know, we've had several devices we've been building over the past 30 years. Most recently, we've had multiple iterations of our Mesa, very successful handheld tablet. And we also have our Mesa Pro, which is our large format, full-size PC type tablet device. And now we have the Archer 4, which has been out there a little while now. It's been a very successful product. It gives you something that is kind of, in, some people might still use the term phablet, somewhere between a phone and a tablet. A little more on a 6-inch screen device. It's basically a rugged device that's pocketable. It runs Android, and it's currently on the Android 14 Google Mobile Services operating system. It is certified, it is upgradable. This is designed to be something that exists as a professional product, so we'll be able to upgrade this to follow-on versions of Android. I think we can go, I believe, up to Android 18 whenever that releases. So the product has designed for a long life cycle. It has the newest processor on board, a lot of RAM and plenty of storage built in, and a very bright display. It's the latest in our release of the Archer line, which Archer brand products are what we call those products that are pocketable computing solutions. It's got 5G cellular capability with 4G LTE fallback. It's not designed to be used primarily as a phone, but it is designed to connect to cellular networks. If you want to use voice on those networks, if you have support on the service contract you're using, that'll work, of course. It does have dual SIM card support, which is very useful for people who may be using multiple services from different providers. And the battery is an all-day battery, and it's a hot swappable battery. So if you need to change the battery in the field, if you're carrying a secondary battery, you can do that. And like all of our products, we use the term Juniper Rugged, which means that we test it to a series of different types of environmental and stress tests, including IP68, which is waterproof and dustproof ratings, and Mil Standard 810H, which is a series of tests we do for durability of rugged products, including testing the temperature range, testing its drop, shock, vibration, things like that. All right. Along with the Archer, we have a complete ecosystem of supporting accessories for the product, including you can purchase a larger battery, an 8,300 milliamp hour high capacity battery. And this will give you 16, 20 hours of runtime potentially. There's a hand strap holder that comes in the box when you purchase the product, so you can use a little Velcro hand strap. We do have a couple of accessories like a 1D and 2D barcode imager that you can add to the expansion area on the back of the product. And what we're going to be talking about today is our GNSS Expansion Pod. And we already have a number of customers out there who are using this expansion pod. What we've done most recently, and the purpose of this webinar, is to go over a new feature that we've added to the product. Now, when we talk about the expansion pod, effectively the Geode has two GNSS receivers. There's the internal receiver, which is built right into the processor. It's a component chipset that's part of the main processor for the device. It's a L1, L5 dual frequency receiver, and it'll get you 2 to 5 meter accuracy of an autonomous solution. Now, this is not a receiver that can receive corrections. The reason it's dual frequency is a lot of these small base component resource grade GNSS receivers can use dual frequency to cancel out things like ionospheric error. So it's kind of like what you might see with SBAS when you don't have an SBAS correction service. So you get a couple meters, you get pretty reliable performance pretty much wherever you are. And it is multi-constellation, so it uses GPS, GLONASS, Beidou, Galileo, all the constellations that are out there. Now, adding on top of that, if you add the expansion, that's our expansion pod. That's a U-Blox F9P receiver. Now that is a L1, L2 dual frequency multi-constellation receiver, and it does support multiple forms of corrections. It supports SBAS, which will get you a meter or better solution. We've seen basically sub-meter performance with people using it. And the receiver engine is also capable of doing RTK when RTK data is provided. So that's what we're here to talk about. The expansion pod itself, this is just a little image from the supporting quick start guide that's packaged when you buy one of these expansion pods. To attach it, you have to pull off these two little plastic covers that are over the connectors on the back of the Archer 4, and then you insert the expansion pod. There's a little tooth on the bottom, insert into the bottom of the expansion area, and then you attach 2 screws to fasten it down. And that's how you attach the expansion pod to the receiver. It's not a quick snap-on. It's designed to be a rugged solution, so it's something that you attach and bolt on. And once it's on there, it has a nice positive connection to the port on the back of the device. So one thing you need to know is which receiver are you using? So when you put the expansion pod on, you have the ability to choose using the internal receiver or using the GNSS expansion pod. So what you have to do is go into a control panel in the operating system and select Use U-Blox USB GPS. It's a U-Blox receiver engine. It's attached to the USB port expansion on the back of the device. So that's what you're going to do. You're going to go into the menu, select that item, and turn it on. Now, when that's active, the GNSS expansion pod takes the place of the internal GNSS on the processor. So the expansion pod becomes the internal GNSS as far as any applications are considered. And that's actually very important. We're going to explain that a little bit later. GNSS pod turns on because it's the internal GPS now. The pod turns on whenever a location-based application is active. So say you open Google Maps, boom, immediately the receiver turns on. So you turn off Google Maps and you turn off any other app that might be using location info. Then the receiver switches off. The important thing to know is when any location-based app is running, the pod is active and it is using additional power. So what we're here to introduce today is the Archer 4 GNSS expansion is now RTK capable. So you can get centimeter level accuracy right in your hand. Part of this includes our new Archer Connect utility app. This is downloadable from the Google Play Store. And probably the best part is all existing GNSS Expansion Pod users can now use this feature. All you have to do is download this app. And if you bought the Expansion Pod to add sub-meter capability to your Archer 4, now with this app, you can also get centimeter accuracy by using a RTK correction service. Okay, so real quickly, I'm just going to touch on what is RTK. I'm sure many of you know this, but in case people aren't familiar, you're going to hear terms like RTK and N-trip. So RTK means real-time kinematic GNSS. It's a method of calculating vector data, or distance and direction, between a known position, traditionally called a base or base station, and an unknown position, which is you, the handheld, the rover, the thing that's roving around. And it does this by delivering base station location data to the rover in real time. That's why it's called real-time kinematic, or real-time moving. That's what it means. RTK can be a single base traditional setup where you have a rover and you have a base, or you could use network RTK, where you have a network of bases and your rover logs into that network. And that's done using what's called N-trip, which is an acronym which means Network Transportation of RTCM Data via Internet Protocol. And that's a mouthful, so it's an acronym with acronyms. Basically, that is the method that the Archer 4 uses to do an RTK solution. Now, traditionally, RTK can be delivered via radio, or in our case, it can be delivered over the internet. So one thing you'll need to use is the cell modem feature inside the Archer 4 to get the RTK solution. Okay, what about network RTK services? So you need a service provider who has an RTK network for you to do RTK with your Archer 4 with the Expansion Pod. Now, there's all kinds of networks out there. The Archer 4 requires the RTCM version 3 format of message. Don't worry, pretty much all RTK networks out there use that format. Even some networks that are more proprietary that might use something like a CMR or CMR Plus, they also typically also output an RTCM message. There's services available that are traditionally, city or statewide or other private networks. Many states in the United States and provinces in Canada, these are run by departments of transportation. There are regional multi-state networks. This example here is actually just a screen snap from our Utah reference network. And in fact, you can see it covers Utah, goes up into Wyoming, Nevada a little bit, covers some of the bordering states where there are shared agreements. There's also national and multi-country networks. For example, you could use the Archer 4 with Point One Navigation's network, which covers all of the US, covers most of Canada now. This map is a little bit older. Covers pretty much all of Europe. They also have coverage in Australia and South Korea and Japan, and pretty much wherever there's populations who need high precision, that's where you're gonna find these network services. There's a lot of them out there now. There's Point One Navigation, which we're familiar with, and we have a lot of people using that. Another really good one is Skylark services from Swift Navigation. GeoNet is another popular one. So you're starting to see more of these large multinational, international networks coming up. Even TopCon has their TopNet Live, which has quite a bit of coverage around the world. So there's lots of networks out there for you to use. It's really your choice of what service works best in your environment and what price point meets your needs. Most of these are all subscription-based. Some local states, for example, Massachusetts, I believe their network is provided for free. So you want to check if there's a local network that you can access for free. Okay, what about, how does it work? What's the performance? So this is just sort of an image here, a graph showing the different performance levels you can get now with the Archer 4, with the Expansion Pod. So the big blue area, and this is just a map grid of X and Y, say east and west, left and right, and north and south, up and down. And that big blue donut, that's basically where the internal chipset receiver performs. It gives you somewhere between 2 to 5 meters reliable accuracy. If you have the Expansion Pod attached and you're using SBAS, then you're going to see something a little bit better than meter. That's going to be that green area. And if you connect to an RTK service, you're going to see that 1 centimeter dot. You're going to get a very high precision location. So what's that look like on the device? Just a little quick sneak peek here. This is the home screen in our Archer Connect app, and some of you who are familiar with our Geode product will recognize this screen. We took basically the main portion of the code for our Geode Connect app utility, and we rewrote it for the Archer Expansion Pod. Since it's a different GNSS engine, we had to put different commands in there. But we kept the layout because a lot of people said they like the information that they see on the screen and how it works. So this is what you see on the home screen. If you're connected with SBAS, you'll see you have a differential GPS solution. And in the upper right, you'll see a little icon for a satellite. That'll change color depending on how good the signal is. Usually it'll be green or blue. And down at the bottom, you'll see the correction type is SBAS. And then to the right side of the screen, you'll see your estimated horizontal error, estimated vertical error, things like that. So here's an example of some data we took a few weeks ago outside our building. Now, granted, it was bad weather, and weather can have an impact on your solution. But looking east and west and north and south on this grid, and each little square is 0.2 of a meter, so about 8 inches. You can see here that we're somewhere between about a meter in any direction, a little bit better for a bunch of points we capture around the building. That's on your horizontal. On your vertical, it's not quite as good. This is one of the limitations you have with SBAS, and also with all GNSS positions, your vertical is going to be about, you'll hear different people quote different numbers. They might say 1.5 times, they might say 1.7 times, they might say 1.9. It depends how you're doing the math and how you're calculating it and what your reference is. But basically in this particular test we did, we saw that our vertical was actually floating around a fair amount. We actually jumped up to a little bit more than a meter in this instance. And like I said, we were having some bad weather at the time I did this, but I wanted to see how it would behave in this particular run. And that's roughly what we got. So we saw sub-meter horizontally and a little over a meter vertically. Okay, what about RTK? So when you're using the RTK network correction service, you'll get a little icon that looks like a plug that connects in the top right, indicating you have RTK running. At the bottom of the screen, it says the correction type is RTK. And when you get an RTK fix, this is one of the things you'll learn about using RTK. You have 2 modes of operating. You have what's called a float and you have a fix. When you get a float, that means it's solved a solution with one satellite between a base or network source and the rover itself. When you get a fix, it's solved all of the common satellites, basically the vector, the distance between the network and the rover for all the satellites. And when you have an RTK fix, you'll see the estimated error on the right is 1 centimeter. So pretty good. So sub-inch. This is what it looks like. This is about 35 minutes of data on the screen right here. And you can see that we're, if I go to the left a little bit, if I go straight west, I'm at, well, less than a centimeter. And same thing to the right. So overall, I'm about 1.2 centimeters in this scatter on the ground. And vertically, I apologize, the scale vertically here is a foot. It's marked off in metric, but this is 30 centimeters, so that's a foot. And if you look at the scale bouncing up and down over 36 minutes, we had about 3 centimeters accuracy on vertical. So pretty good. Now, what's that do to your battery? Okay. If you have an Archer 4 and you're running a little GPS app, there's one out there called GPS Test, which is a great little app for trying out your product. And you're just using the internal receiver. That'll run 18 hours in testing that we've done here with the big battery. This is using the larger 8,300 milliamp hour battery. If we use that internal GPS and we run our mapping app called Uinta, which is a full-size app, and that app is running and logging points to a line feature, and it's got a map view, so it's actually using the processor pretty heavily in this test. We see a 13-hour runtime, so still pretty good. Now, if you use the GNSS pod and you run SBAS with Uinta in the same environment, well, we see about 12 hours of runtime, so about the same, a little bit less because the receiver is consuming a little bit more power. If you run RTK, now you're running your data collection app. In this case, we use Uinta. You're powering the GNSS pod. You're doing an RTK solution, so you're using more horsepower of the receiver, and you're connected to a cell network because you need that data source. We still get 8 hours of runtime. with the big battery doing all those things. So the moral of the story here is we strongly recommend, if you're going to use the RTK feature, get the big battery. And Wyatt, you tell me, how many people buy the large versus the regular battery?
I would say it is about 90% at this point. There's only a $100 list price difference between the two models. So for me, it's a no-brainer. I would absolutely go big battery all the way.
Do you think that changes how the weight feels in your hand?
Not noticeably that I've found. I also have found that I like the ergonomics actually a little bit better of the big battery. There's kind of a groove that your pointer finger that is holding the device kind of naturally finds and just fits good in the palm of the hand with that hand strap behind it, holding your hand to the device. So yeah, I'm a big fan of the larger battery for sure.
Great. Okay, I'm gonna spend a little time here and touch on the Archer Connect app. To use the RTK feature, you need this app, or you need an application that has written into the app the ability to do what we're doing here. So we are working with some developers who have asked, and we can provide them the content information. We have that on the developer section of our support site that explains how we do this. But to use the feature, or in fact, if you just want to manage the device yourself and see a little bit more as what's happening, you can download the Archer Connect app. It's a free app. We provide that as utility for the product, and it's just in the Google Play Store. When you fire it up, what will happen is a little home screen will pop up. It'll look just like this. In the upper left, there'll be a little icon, and that indicates that you are connected to the expansion pod. If you click that, you can disconnect, which will power down the pod. So that's one thing to watch for, is make sure that the pod is turned on when you launch the app. And you'll be able to tell probably because you'll see some data on the screen. The app is designed as a configuration utility, and when we launch it, normally it just turns on the receiver automatically, and you can turn on and turn off the pod. But remember, you do have to have the pod enabled in the operating system, like I showed earlier. So make sure you go into the operating system, enable, use u-blox USB GPS, and then launch the Archer Connect app. Now, the app also runs as a service. So it's not just an application, but it's also a service, which means it's some background code that could be running even if the app is closed. So if I were to launch the application, maybe connect to an RTK service, get it running, and then close the application, if I go to the information screen in Android by just dragging with my finger and swiping down from the top, it'll show what services are running, and you'll see the Archer Connect service is still running. This feature allows you to have the app closed, but to still have the receiver running so other apps can use the receiver without powering the receiver down. The app will need to remain open, for example, if it is being used as an N-trip RTK provider. Doesn't mean it has to be in the front screen, because it also runs as a service. It just has to be open. So the best practices when using the app is you open the Archer Connect app to configure the pod, then minimize the app, then open your data collection app and do whatever you need to do. When you're done, close your data collection app, then disconnect and close the Archer Connect app. And it's always good to double check, make sure that service isn't running. If it is, you can just click manage, you can click disconnect, that'll shut it down. And the reason I tell people to do this is because if they forget to do this, and then they press the power button and suspend their Archer, the screen goes dark, but they then take it to their office and set it on their desk. In the background, that receiver's still running, and they come in the morning getting ready to go out to the field again, and the battery's dead because it's been running all night long. So something to be aware of, something to watch out for. Best practices, make sure you disconnect that app when you're done. Okay. So one thing we did add to the home screen is a lot of people were asking us, hey, can you put the vertical arrow in there too? I'm like, yeah, sure. So we added that feature on there. And then something to understand when we talk about a service, the app that we built, we did some work on the operating system, which is kind of neat. The application connects to the receiver engine through what's called a TCP port, or a virtual port. What that means is that means any app that you use that you might run on an Android device, or like our Archer 4, that you connect to the internal GPS, works the exact same way on our product as it does on anything else. You can have Archer Connect running. Pardon me for that. So you could have Archer Connect running. You could have it providing a correction service, Your app just needs to connect to the internal GPS because the receiver, remember I said, is the internal GPS, which means you don't need to do any additional coding. Things just work. You don't need to create a mock location provider. You don't have to have additional code so that your apps can read NMEA messages along with the location services. It just works, which is what we're shooting for our customers out there. Okay, there's also a sky plot screen, shows you where the satellites are in the sky. This is helpful just to see the working environment you're in if you're getting signal. There is a terminal view, and some customers and our dealer partners use this as a diagnostic tool. If you're having a problem out in the field, we might ask you to fire this up and tell us some things as to what's going on. And then, of course, there is the settings screen, and this is where you can configure different settings like the data rate coming out of the receiver, the NMEA precision, and we set up the default to be the highest precision, or 7 digits from latitude and longitude. The elevation mask, the default on the receiver engine is 5 degrees. You can raise that to 10 degrees if you want. And then the correction sources, SBATS and SLAS. SLAS is specific to Japan. Those are all default enabled. RTK is always ready. So it's always enabled as a correction. You just have to provide the RTK data to it, and then the receiver automatically switches to RTK mode. And of course, there's a reset, and then there's where you can access the RTK menu. Just a little technical note, when we talk about NMEA 0183, this is a industry standard message format. So a GPS receiver will output different messages, and the most common format is NMEA 0183. And these messages are different pieces of information like your latitude, your longitude, your accuracy, that type of thing. So the receiver engine has, I think we have about 6 messages that are turned on. And then through Archer 4, we turn on a whole bunch of other messages. So effectively, we turn on all the NMEA messages that pretty much any application out there will need. Again, making it simple, easy, plug and play for users out there. You don't really have to get in change these settings. Now, you may notice in the app there isn't a selector for NMEA messages. That's because whenever the receiver is powered down, it defaults back to just these 6 messages. That's another reason why we use our app to turn the other ones on. Okay, so how do I use RTK? Well, you're going to go into the settings and you're going to click on the Ntrip RTK configuration. And this is where you put in your credentials, your login information to get into an RTK network. You'll put in the address and the port number and maybe your username and password if your account requires that. And then you will click save and you'll click download mount points. Now, mount points are different sources for corrections in a network. And many networks will have different mount points with different datum references. In other words, different models to the size and shape of the Earth. I'm not going to go into a deep description of datums, but just so you know, if you go out and try to take a receiver in your phone, say you take your phone out and if it were capable of getting high accuracy, and you walked over to a known control point or monument or benchmark, and you looked up the latitude and longitude of that, and you walked over to your phone and you say, wait a minute, it says I'm 4 feet off. The receiver is not working. No, that's not what's happening. What you might be experiencing is a datum shift or a datum difference. That's why you have in many of these networks the choice of different datums. So you want to choose that, and at the bottom you'll click the little save icon, and that will save all these settings into the app. You can also save a profile, which means you can put all the information in, save it as a profile, then you don't have to log in any more times when you go back to it. You just launch the app, launch the RTK correction service by saying start Ntrip or RTK, and it connects. Which also means if you have a group of workers and they're all using a similar network login, you can save that profile and share it to other people so they can use it. Just remember, you're sharing the login info also if you've saved that, so you want to be careful with your passwords. It also means if you're using multiple networks, you can save multiple profiles. We do have a little feedback help feature. So if you're just experiencing some strange problems, you want to reach our tech support, there's a little help button. You can click that and it launches a little email form. You can fill that out, put your notes in there and send it to us if you need to send us an email. Okay, another technical note. This is getting a little into the weeds, but some people do this. They might want to transfer data sort of the traditional old school way of plugging in their Archer 4 with a USB cord into their PC. Now, something to remember is the GNSS Expansion Pod, remember I said it connects on the back to a USB port. When the receiver is connected to the USB port on the back of the Archer, that will disable the data port, the data USB port on the bottom of the Archer, if the receiver is enabled. So if that's enabled, you can't use USB debugging and you can't use file transfer at the same time. You can disconnect the receiver, turn off the GPS receiver command in the settings, and then you can use the USB debugging. But most people nowadays, you can use wireless debugging as a way of moving files, but a lot of people are just using Google Drive or something like that. Many apps have sharing or cloud services. So not too much of an issue, just something to touch on if it comes up. This is the recommended configuration for people who want RTK. You take the GNSS Expansion Pod, you add it to the Archer 4, and we typically, like Wyatt mentioned, we recommend the Archer 4 with the large battery pack. And because all of our devices have to be EU compliant, you can buy them with or without chargers, of course. You can order the partner that doesn't have a charger if you already have a charger. Keep the e-waste down. All right. Just to summarize, so the Archer 4 GNSS Expansion Pod is now RTK capable, and any existing users out there, download the app and you can use it. All existing expansion pods are able to use the feature. The expansion pod can be added to any Archer 4 handheld, just attach it to the back. And we do recommend the high capacity battery when you're using RTK because you're using all the features of the Archer 4 and you're going to be using a lot of power. Archer Connect features will be released in a future version also of our Uinta mapping application. Pretty soon, you won't need to fire up Archer Connect to configure the RTK pack and then launch Uinta. You'll just do it directly in Uinta. That's being finished up right now. I don't know when the release date is, but it'll be coming soon. I think we're getting to the end of time on our webinar here. We might have actually gone a little bit long. I do appreciate you folks sticking with us. But if you have any more questions, feel free to email those in to us. And we've got a couple more we might be sending out an email. And I think we're also going to make the webinar available for download later. So if you have someone you need to share this with, to show people what this would do, say you're looking to buy this and you need to show your boss a little more details as to what it does, we'll make that available. Anything else?
I don't think so. Thank you very much, John, for your time. And again, thank you everybody for your attendance. I know we did go a little long. Thank you again for bearing with us on this and sticking around. Again, just appreciate our partnerships, our relationships with you all out there, your interest and your continued business. We really enjoy working with all of you and appreciate your time this morning and this afternoon. For those of you that are a little bit further east, have a great rest of your day, everybody. Thank you.